my mic was off. Hi. Woo. Hi, how y'all doing? I'm gonna turn down that a little bit. Um, Sorry I got started late. This is gonna sound like a fake thing, but it's a real thing. My glasses got stuck in my hair very badly, and it was very scary, and I didn't enjoy it. So that's what happened. All right, let me make sure this is muted, and I need to make sure, nope, okay, it's muted. I need to make sure I've got the other chat up. Let me get that going. Whew, what a morning. Hopefully y'all are having a better day than I am so far. Today, we're going to be continuing on a paper that we started last time. And it is, I got the title up there now, Template Guided Text Generation for Task-Oriented Dialogue by Kale and Rastogi, 2020. It's from EMNLP, which happened 2 weeks ago, a little bit ago, very recently. And yes, so you may remember last week, 2 weeks ago, last week was a Thanksgiving here in the US where I am. 2 weeks ago, we were clicked on a link. We were looking at some of the model evaluation. I believe we got up to section 5.3, but I'm probably going to go through and reread through 5.1. And we got some error rates here, right, that were extremely high, and I was a little bit confused by. So this SER measure here is slot error rate, and they cite for this paper, neural generation, that's language generation for check data and baselines by Dushek and Juristisek. I'm sorry if I'm saying that wrong. I know for a fact I am not gonna get all the Czech pronouns, phonemes right. And that paper cited this paper for that measure, and this paper is Wen, et al., 2015. Semantically conditioned LSTM-based natural language generation for spoken dialogue systems. My ability to use language is not doing great this morning. Bool Machine says, hello, you're an inspiration. Oh, that's very sweet, thank you. I hope you still think that by the end of this stream. And one big question that I had that we're not going to have answered in this paper, I don't think, so this is paper that we were originally looking for, we were originally reading through, is slot error rate here is, as they put it, a metric that counts slot placeholders in the output before lexicalization and compares them to slots in the input DA. So, my understanding, having dug into this a little bit, I asked on Twitter, but I asked during EMNLP, I didn't get any responses. So we'll just figure this out on our own. So slot placeholder is, I believe, the name of a slot. So if you had something like, I want to train from source to destination, source and destination would be the slot placeholders. And are you getting those correct before you put in the words, which is what I'm guessing what lexicalization is? I could be wrong. I'm trying to like feel it out based on sort of my knowledge of related things. And then it reliably measures the amount of missed/added context in all delexicalized slots, but the non-delexicalized binary kids allowed slot is ignored. So if there's a slot that's going to be a word, right, or a string, or in any type, if you were using Rasa, that gets counted, but slots that are just like yes, no, don't get counted. is my understanding. And we were looking at the slot error rates, and they seemed extremely high, right? So like 12 seems really high, so that you would get 12 slots wrong for every one slot that you got right. And then even anything above 1 seems, to me at least, to be extremely high. So I poked around a little bit in these papers because I was interested in seeing what the sort of range for this slot error rate measurement usually is and what sort of things that they were comparing against. What I noticed is that we were right last week, 2 weeks ago, when we said that 12 seems really, perhaps even unusably high, very, very high. And the range in this paper is from sort of less than 1 to around 3. So this is the check paper, the paper that we were reading, the template guided text generation paper cited. And the range for the paper where they originally proposed this measure, here it's called error, not slot error. It ranges from 0 to 8.5, which very, very high, but mostly a lot of instances where it is under 1, and in this instance where it is under 0.5. And this paper is from 2015, so that was really the sort of the early days of bidirectional LSTMs. I don't think we'd really gotten to using attention much at that point. And this would have been right smack dab when I was in grad school, right in the middle of it. Bool Machine, I can't find an FAQ. Do you have one hidden somewhere? Not really. So I'm building in the live coding an FAQ chatbot for my personal website that is not up yet. I should just put it up. It's got some functionality. Yeah, so not really. If you have any questions, please feel free to ask them. But the one thing that I really want to point out here is that we have a method. So this is the 2015 paper that the check paper, which is from 2019, cites, is that we have a method that has 0% error. If you're familiar with machine learning methods, that's always a little bit surprising because machine learning is at its heart fancy guessing, and you're almost never going to guess correctly 100% of the time, and if you are, there's probably something else going on that you should look into. So really low error rates tend to be, like an error rate of exactly 0 tends to be a little bit questionable. But the HDC here stands for handcrafted. So you can get no errors if you are using a handcrafted way of doing things. So this would be, basically this is what we do in Rasa, right? We have templates, so we have sort of like the sentence, and then we have like, I'm going from source to destination, and then we look up source, and then we look up destination, and then you plug them in. You can do this in other ways, of course, but this is sort of the simplest way that we recommend. You plug them in, you tell that to your user, hey, it works, and you didn't lie to them. And the neural methods where you're trying to get around having to build those templates that you plug in slots will just introduce errors. I mean, they'll do other things as well, and I think there's definitely places where it makes sense to use those methods, but just so you know, you could end up in a situation like this one where you're getting, 12 slots wrong to every one that you get correct. So you're going to, if you're just as a commercial application, like lie to your customers 12 times before you tell them the truth once, which I wouldn't recommend. And even, even anything above 1 here, I think seems extremely questionable, and 0.5 is still, that's high. That's really high. Anyway, but this paper, I don't think they're recommending that you immediately put this into production. It's a very specific type of project. Gagandeep, good to see you again as well. Welcome to the stream. Welcome back to the stream. And just as a little refresher, what they're thinking about here is a single method that you can use. It has been 2 weeks since we read this, so I'm a little bit fuzzy on what they said. So let's just really quickly check in with the abstract and reread that. Blah, blah, blah. They interact with a large number of services and APIs on the web using natural language. So you might ask your, virtual assistant, I want to book a taxi, and it might point you towards, a service, a third-party service for taxi booking, but there may be only an API surfaced, so then the assistant needs to have a way of taking an API and creating a natural language utterance. In this work, we investigate 2 methods for natural language generation, NLG, using a single domain-independent model across a large number of APIs. That's what I just said. First, we propose a schema-guided approach, which conditions the generation on a schema describing the API in natural language. So maybe you have the docs, the documentation for the API, and you use that as input to produce the output of the natural language output that you would serve to users. I'm assuming it's users here, sort of based on their use case. It could be something else. Our second method investigates the use of a small number of templates growing linearly in number of slots to convey the semantics of the API. And templates are just, you have like a skeleton sentence with the things that you are the pieces of information that you're gonna fill in removed, and then when you say the sentence, you replace the slots with the information. I don't know if I explained that well. So instead of like source and destination for your taxi trip, you'd say, I'm going from, I don't know, Queen Anne to Magnolia. If you were in Seattle, those are 2 Seattle neighborhoods that are right next to each other. You'd probably walk, but to generate utterances for an arbitrary slot combination, a few simple templates are first concatenated to give a semantically correct, but possibly incoherent and ungrammatical utterance. So if you're asking for multiple slots, we're just going to take our existing templates, squish them together. A pre-trained language model is subsequently employed to rewrite it into a coherent, natural-sounding text. So you take that sort of disjointed sentence, you run it through, a transformer model, and out you get something. I think they use T5 as their transformer model. Through automatic metrics and human evaluation, we show that our method improves over strong baselines, is robust to out-of-domain inputs, and shows improved sample efficiency. Better than a given baseline, although in this case it looks like their baselines are other NLG models and not handcrafted templates, which I would say for the majority of conversational AI projects, handcrafted templates are a good baseline. This particular application it's interesting, right? It's the instance where you and your team are building a virtual assistant that's connecting to a lot of different APIs, and those APIs don't haven't already passed you high quality language data templates to send to users. So basically you're using, a language interface to APIs that were not designed to be used with a language interface. This is not an application I see. I don't know, a lot of people like ask me questions about different stuff. I think this is honestly the first time I've ever heard of an application like this. It makes sense that this work comes out of Google because they have a virtual assistant that does this. Google Assistant, I think, is just what it's called. But I would say for the majority of projects that I'm familiar with, usually it's a team building a assistant that's very focused on their particular need, and it makes sense for them to have handwritten templates as a baseline. And sometimes those templates are written by engineers, but if you're familiar with conversational designers, they're usually the people who will be like, okay, you want your assistant to be friendly and knowledgeable and sound like they're from Surrey in England, so we're going to design conversational assistant turns that give people that impression. is sort of the job that does that. So yeah, that's all I have to say there. But of course, the bottleneck there is how long does it take you to write good templates for your assistance utterances. And if you have, 20,000 APIs you're trying to connect with, maybe it's not feasible to do all of them through, through handwriting rules. But I guess my second question there is, if you don't have time to hand validate all the things your assistant can do you really want to be putting that in front of people? Yeah? I don't know. And again, I know sometimes you'll hear people refer to things as being Google scale, which just means really big. I think this might be an example of one of those projects. Anyway, back to the evaluation. Actually, I think it might make sense to peek a little bit into their thing that they're doing here, because it has been a couple weeks for me. So let's see. Okay, so these are the different ways that you can do it. So naive is just naive. The most basic representation, canonical representations of each action, depending on the parameters present in the action, are concatenated together to obtain a sequence. So then here the assistant is just informing, and the restaurant is OPA, and the cuisine is Greek. And what makes this naive is that this is not super informative, whereas this sort of slot name, type of food served, or name of restaurant is a little bit more informative. Because you could have an example where like the restaurant slot is false because someone asked, does this hotel have a restaurant attached to it, or something similar to that. So I can kind of see that. And then the template guided is generated by concatenating sentences obtained from the two templates, which are inform, restaurant, $, how about restaurant, $, inform cuisine, $, the restaurant serves, $. How about restaurant, slot name, it serves slot food, and then the ground truth is, I guess, human generated here. So basically they're saying that this is more fluent sounding than the template guided, I think. And Bool Machine says, sorry if I'm off topic, but I'm really struggling with a future career. I'm a senior student in CS and have two options, which are working as a backend dev right now, or go to finish my master's and be an ML engineer, specifically interested in computer vision. What are your advices as an expert in NLP and NLG, and what would you change in the past if you had the chance? Yeah, so my general advice to everyone is not to go to grad school. And I realize that's my general advice to everyone, regardless of their background, unless your specific goal is to be a researcher or a professor. And even then, going to grad school is no guarantee that that's going to be the job that you end up in. And it's just like a lot of time and money. So if you can get a job without going to grad school, I always recommend that. I am increasingly leery of computer vision as a field. I think there are, of course, good applications, but I think that there are so many applications that are ultimately more harmful than helpful that I would not be interested in working in the field. And that's just sort of my personal stance. So I would probably go for the back-end role, but also I would rather be a back-end dev than a machine learning engineer specifically for computer vision, so That's my advice. Yeah, what would I change in my past? I don't know, it's hard to say. Honestly, I would have taken more graph theory if I just like had the chance. You'd be shocked how many places graph theory comes up. Yep. All right, so how is Benson? Benson is my dog. He's very good. It's chilly this morning and he did not want to go for his walk, so he was a bit grumpy when we came back in, but he's good. He's curled up in front of a heater. Yeah. All right. So going back down. Wow, I don't remember a lot of this paper. Mostly I remember the thing about the slot error rate that I was surprised by. Let's start with the automatic evaluation, I think, because that's where we really got deep in the rabbit hole last time. Oh, you're very welcome, Bull Machine. I hope it helped. I don't know. At this point, anyone who has not been on the job market for the first time in the last like 2 years or so is probably not going to have the most relevant answer to job questions. It's just, it changes so fast, especially like with everything. Good luck. Following prior work, we used blue and slot error rate. Okay, so when is the paper that came up with slot error rate? Oh, I bet these citations are backwards. I bet this citation was supposed to have been, hey, these people use blue and slot error rate, and this citation was supposed to have been, this is the people who came up with slot error rate. I bet that's just like a little typo. SER represents the fraction of generated text where at least one slot was not correctly copied from the structured data. Since this metric relies on string matching, we cannot use it to evaluate binary slots like has live music. Its exact match nature also prevents it from identifying paraphrases of slot values, e.g. expensive and costly. For E2E end-to-end, we used additional metrics used in prior work for this benchmark: NIST, Rouge L, Meteor, Cider, and Blue. So really just going for sort of a little potpourri of different text evaluation matrices. Metrics. Table 2 lists the result on multi-WAS and table 3 on E2E. Oh, maybe it's not end-to-end. Maybe it's a data set that I don't remember the name of. We train separate models on each data set. On both data sets, T2, G2, and schema are comparable to the state-of-the-art naive approach. Oh yeah, I remember this is their acronym that means like template guided text generation. And the acronym does not map super good to the thing that they're acronyming, but no one ever accused NLP researchers of being super good at naming things, so I've come up with bad names my own self. We note that the SER score on multi-WAS is slightly worse than in comparison to SCGPT. SCGPT generates 5 predictions for each input and then ranks them based on the SER score itself. On the other hand, we generate the single output on which SER is evaluated. This model has already gone through some evaluation based on this metric to filter the ones that have the best output. Overall, the results indicate that with enough annotated data, the naive approach is enough to attain good performance. Both datasets are large and feature limited variety. Zero-shot and few-shot settings offer a greater and more realistic challenge, and we explore those settings next. So what they're saying is you can do okay. So this one is multi-WAS, just using the naive approach, which is to take the slot names and generate templates from those slot names. And it works pretty good. And then this is their approach, the text template guided text generation. I have to look at my own video title. That does pretty well based on these metrics, and is sort of in the same range as Blue, and it's really this STL STM that is not very close to the rest of the models. Adapting to new domains. So this is the thing that they are really excited about in this paper, is that they want to be able to have a single system that works for a lot of different domains. Handling a lot of different domains. We report the results in table 4, seen and unseen. Oh yeah, I remember this. There was something very funky where the unseen ones had better performance. Seen overall, the naturalness. Maybe it wasn't this one. Yeah, here we go. So the unseen were worse than the seen. What are these? Blue and SER metrics. On the SGD dataset. So this is blue. Higher is better. And this is error rate. Lower is better. So, and then the bolding is for the best in each row. So unseen blue was lower than it was for seen. So these are the categories that it is seen before, categories it is not seen before, and then overall. So for this, blue was worse for things it hadn't seen, better for things it had seen, and then sort of split the difference overall. That makes sense. And for error rate, it was lowest for things that had not been seen and was higher for things that had been seen. And this is very weird to me, because you would expect your error rate to be lower for things that you had previously seen than for brand new information. And this is true for all of their approaches. Except for copy, which has 0 error because it is a trivial baseline comprising of the template-based input representation and has 0 rate by definition. So this is just sort of using templates. They're always right. I mean, I'd recommend them even if they don't sound necessarily quite as natural, because at least for the applications where, you know, most of the folks I talk to are working on, it's more important to be correct. Maybe if you're working in like games or something where you know, having a sort of like a natural, well, even then it's like if you ask what's in your inventory and it's like, you have 12 ostriches, and you're like, I do not, that would be frustrating. Anyway, and that was the adaptation. And in figure 5, we list a few examples of model predictions. The first example illustrates a case where the model has to deal with a seen domain flights, but an unseen slot is nonstop. Ooh. Such a case would be common when new functionality needs to be added to an existing domain. So somebody's added an API endpoint. Both Naive and Schema were unable to verbalize the slot correctly. While the template input contains all the information, it sounds very robotic. T2G2, on the other hand, takes 4 template sentences as input and rewrites them as a fully accurate but much more natural sounding response. I don't know that that's fully accurate. Sorry, I'm just looking at this this error rate, and you know, if you have 10 slots that you filled, you're going to be wrong on 4 of them, which is high. I think they're just saying this is an example of a place where it did pretty well. So here we zoom in a little bit. So here we have actions, flights, offer, and then a bunch of information that you might get from a database or an API endpoint. The template, would you like to fly with American Airlines? The onward flight. That's a buck wild way to say that. Takes off at 2:40. It is a direct flight. The tickets cost $78. Perfectly correct. I would be fine with being served this by a robot. Reference, do you wish to fly on American Airlines? The onward direct flight leaves at 2:40 p.m. and the ticket price is $78. The ticket costs $78. So this is the reference for the blue score? Huh. There's some weird repetition there. And then naive, there's an American Airlines flight leaves at 2:40 and is not stop. The ticket costs $78. Schema does the same thing. And this one paraphrases. How about an American airline flight that leaves at 2:40? It's a direct flight. So direct flight and nonstop. Yeah, those are synonyms. I'll accept those as synonyms. Those mean the same thing. And costs $78. I will say, this does sound good. This paraphrase does sound good. Very fluent. I would also not be upset with just being served the template, honestly, personally. The next example is from rental cars and features an unseen slot, has insurance. Schema fails to mention this slot. Naive attempts to verbalize it, but uses the wrong word, reassurance. T2G2, however, is able to paraphrase the template input into grammatical text without dropping any information. We'll back up. Okay, so we have this example. Rental cars confirm, has insurance true, car type hatchback. Please confirm the following details. It is a hatchback car, it comes with insurance. Please confirm, you want me to book a hatchback car with insurance. Please confirm, you want me to reserve a hatchback car with a reassurance. Please confirm you want to rent a hatchback, and then T2D2. Okay, please confirm that you'd like to have a hatchback car with an insurance. That sounds a little funky. You don't usually use an article or a determiner when you're talking about insurance. Honestly, here the template sounds best to me. Reference is also pretty good. I believe the references here are handwritten. Zoom out a little bit. Along with the 16 actions, their template-based representation and the reference output. Yeah, so I think this might be handwritten, this reference output. The errors are underlined. All right. And then the third one, the final example features an unseen slot starring from the movies domain. Naive and Schema treat Antonio Bostrov? Antonio B as a director since the slot directed by appears during training. However, T2G2 simply relies on the template output and copies the phrase acted in. We refer to the reader to Appendix F for more qualitative examples. So example, media information starring Andrea Martin. These are all wrong. All of these are factually incorrect. Here it says that the movie star is this person. In every single one of these outputs, it is this person. I'm wondering if there is an error here. And what they're saying is that the error here is that these are identified as the director rather than the actor, but also that is not the slot. I'm gonna be honest, this first example, which is probably cherry-picked. Cherry-picked means when you pick the best thing from your output to make your system look good. That's pretty good. This sounds a little bit funky for their system. And these are all just like wrong, or this is a typo, one of the two. Are they gonna talk about it? Nope, they think that sounds like that's the correct one. I don't know. If you haven't gotten that impression yet, I think this is an interesting paper that has an approach that I would personally probably never use, is where I'm at right now. But we'll see what they say. Also, I've never had to design a system that had to handle, 10,000 different APIs. We conduct a human evaluation study via crowdsourcing. Examples of the rating UI can be found in Appendix E. Each human rater is shown the responses generated by different models and the ground truth response in a random order. Following Peng et al. 2020, that shouldn't be in parentheses, they estimate each response on a scale of 1 bad to 3 good along 2 axes, informativeness and naturalness. Interesting. Likert scales usually aren't 3-point, but I guess it's like a square, so they're just like, because they're doing multiple ratings, you're probably going to get higher retention if you use a 3-point scale rather than a 5 or 7 or a 10-point scale. Informativeness quantifies whether the response contains all the information contained in the dialogue acts, whereas naturalness evaluates whether the response sounds coherent, grammatical, and natural. Each example is rated by 3 different workers. The final metric is the average of all ratings. I really do like that they pulled these apart following, I think, this other thing. Have you read this? Thought natural language generation for granted dialogue. It sounds familiar, but I don't remember if it sounds familiar because I read it or because there's so much overlap in papers. I do really like that they are peeling apart naturalness and informativeness because I think that's something that, especially with neural language generation, can be a little bit misleading if something sounds, if you just like ask how good it is and people are like, well, yeah, it sounds like a human would say that, but it's like very factually incorrect, then that's not super helpful in this particular application. So I do like that they do that. A total of 500 randomly chosen examples are rated, 250 from each seen and unseen domains, across 3 models as discussed above, and the ground truth response human. With 3 ratings, for example, this leads to total of 6,000 ratings. Results are shown in Table 5. Naturalness. On the overall test set, all models outperform the human-anchored ground truth. This showcases the strength of pre-trained language models in generating natural-sounding utterances, echoing findings from prior work. Are they saying that every single NLG model was rated higher than humans in terms of human soundingness? Interesting. Okay. Informativeness. Simply generating a fluent response is not enough. You can say that again. It is paramount for the responses to be factually grounded in the structured data so the wrong information is not conveyed to the user. For informativeness, we notice that all models perform well on the seen domains. However, on unseen domains, the naive approach fares poorly. Schema outperforms naive by a large margin on unseen documents. T2G2 further improves upon schema. These results suggest schema and T2G2 offer promising avenues to improve the zero-shot generalization capability of NLG systems. Moreover, both naive and schema see large drops on unseen domains, while T2G2 performs equally well on both seen and unseen domains. This is very surprising given their automated analysis. Right? In their automated analysis, all 3 systems were better on unseen domains than seen domains, so there's something wrong? Like there's an error in the model reporting, or it's just something very funky happening that they don't talk about in more detail? I recall that the naive representation demonstrated strong scores for the SER metric for unseen documents. However, the low human scores on informativeness suggest that getting perfect scores on metrics like SER may not be a reliable way to judge factual accuracy. Okay, so they do talk about it. As models become stronger, better evaluation metrics need to be developed to accurately measure the improvements. Very fair. Okay, so they're saying that yes, those were the automated measures that we got, but they just don't pattern with human judgments. Yeah, interesting. Okay, so let's take a little peek at this. So this is naturalness. Ground truth here is the human-generated utterances. For things that have been seen, the naive approach was better. For things that haven't been seen, T2G2 was better. And then overall, T2D2 is the best. So this is a 3-point scale. Although none of these, I guess they're closer to 3 than 2, right? But no, they're not. They're closer to 2 than 3. Okay, and then for informativeness, yeah, I do want to see the sort of way that they phrased this when they were asking their human participants. Because it is surprising to me that this diverges so much from the automated error rate, because you would think that they would track pretty closely, yeah? Interesting. Yeah. And this is just basically saying what they were doing. The superscripts 1 to 4 indicate that a model is significantly better than naive schema T2, G2, and ground truth respectively, as determined by a one-tailed paired t-test with p less than 0.05. You're doing a lot of multiple comparisons there. I would probably have alpha adjusted that. And also, I would have you defend your choice of a one-tailed test, because it's easier to get significant results with a one-tailed test than a two-tailed test, basically. Yeah. I'm happy to see statistical evaluation. I probably would have made different choices here personally. All right, and let's go down and check in the appendix. They said it was E, right? I know that there was a... Okay, human evaluating naturalness. Bad, average, good, bad, average, good, bad, average, good. Okay. Please confirm that the responses can cover the following information in any order. Ada Immortals, San Francisco, 12:30, March 5th, 2 people. Ada Immortals, San Francisco, 12:30, March 5th, 2 people. 2 people, Ada Immortals, San Francisco, March 5th, 12:30. I would not have used bad, average, good here, right? Because that's like a... I would probably have done all, some, few, or none in terms of the slots that were generated correctly, right? Because there's... So what would be good here if you were rating this? Would it be good if all the slots were correct? Would it be good if 4 out of 5 of the slots were correct? I don't love this task design. I think I would have said... I actually probably would have done a 2. Yeah, I think I probably would have done a 2-point scale, like, are all the slots here? Yes or no? And then have people answer that. I think that would be easier for the people who are doing the task. And I think it also would really get at the core question, which is, was the information correct, and was it all there? And if you wanted to peel those apart, you could say, like, you know, were the slots that were present correct, or were all the slots there, and have those be 2 separate questions. I'm glad that they peeled apart naturalness and informativeness. I don't love that they use the same scale for both of those things, because they're different and you evaluate them differently, right? Just like as a human interacting with language. Yeah, that's my stance there. And given this task design, I think that it's not super surprising that you're going to see some differences from slot error rate, which is looking at just how many of the slots were correctly, of the slots that were provided to the users, how many of them were correct. I'm happy to see human evaluation. I don't have a problem with the way the naturalness one was phrased. I think that was really good. The informative one, I probably would, again, have done differently just to make it. Bhavin says, how can we add teams in Rasa? So if you're asking how can you have a team that's working on the same Rasa project, I believe that's a Rasa enterprise feature. So I would reach out to the sales team. Pull that up. Boop, boop. And that is rasa.com/enterprise for more information. Hopefully that helps. Also, I think did we just do I think we just had a blog post about technical or teams who are working on GitHub Action, dialogue management. I think I was thinking about the Rasa for content creators blog post that came out. This one. So I think I was wrong about that blog post existing. Also, there's one on custom actions that just came out today that I know some folks were asking about on YouTube earlier. So hopefully that helps. All right, let's go back to where we were. Yeah, I am very happy they did this evaluation. I'm not entirely convinced by their argument that because SCR did not pattern with this type of human, slot error rate didn't pattern with this particular type of human evaluation. Like, I think the fact that they don't pattern together isn't surprising because they were asking different things. And I would want, you know, if I wanted to compare a human evaluation to a machine evaluation, I would ask the same thing, or I would ask very similar things, rather than having sort of a qualitative evaluation, you know? Anyway, few-shot NLG. Virtual assistants need to support a constantly increasing number of domains and APIs. In order to keep labeled data costs under control, improving few-shot learning methods is important. Yeah, improving is important. In this section, we study the trade-off between number of annotated training examples and performance of NLG. So this is there a method that lets us use less data labeling to get good results? Because labeling data is expensive. Prior work have studied few-shot learning and domain adaptation in a simulated setting by creating small subsets. However, a lack of knowledge of the exact data splits makes it difficult to make comparisons to other methods. Okay, so we've got a small subset of data, but we don't know how the data distribution is going to play out in, you know, situ. To remedy this, we created a new canonical split of the SGD data sets as described below. SGD being one that was like seen and unseen. We make K-shot subsets for varying values of K, 5, 10, 20, 40, 80. In this setting, each of the 14 from domains from the training set have K dialogues. So you're seeing, you know, 5 examples from 14 domains, 10 examples from 14 domains, so 70, 140, 280, etc. Total training examples. For all the few-shot splits, we make sure that they contain examples for every dialogue act and slot type present in the full training set. For every domain, we make sure that each dialogue act and slot is represented at least once. However, all combinations of dialogue acts and slots may not exist. And I think this is a fairly reasonable approach, especially if you have the API and you know what your assistant can do. It makes sense to be like, hey, let's make sure we, you know, have examples of hitting all the endpoints. The dev and test such sets are left untouched. This benchmark is referred to as few-shot SGD, and we make the exact splits publicly available. The exact number of examples in each split is given in Table 6. 6.2 results. In few-shot experiments, we examine the performance of different models as a function of the amount of labeled data. The training setup remains the same as described in Section 4. Results reported in Figure 6, where we can clearly see the performance improving as more training data becomes available. Not surprising, usually the case with neural methods. In all the K-shot settings, T2G2 gives consistent improvements of 4 to 5 blue while reducing SER by a large margin. Even in the extreme 5-shot setting, the SER is just 3.6%. Are these proportions or percents? Hold up, have they been reporting these as percents the whole time? So the reason I'm asking is because if this is a proportion, it's 5%. If this is a percent, no, yeah, no, I guess I'm assuming that they've been... Is this out of 100 or is this out of 1? Yeah, is it 5% or is it 5? Right? Does that make sense? So is this 5% of slots are reported incorrectly, or for every 5 errors, there is 1 correctly reported slot? Yeah? Which is a pretty big difference. Let's check the... I'm gonna check their... Yeah, this is not... So the way that it was originally presented in when 2015 is not as a percent. So if they're doing this as a percent, so this is the Czech 2019 paper. I'm just trying to see if this is a percent or not. Slot error rate. Slot placers and reliably measures. So is this 3 or 3%? Because those are very different things, and it's not entirely clear to me which one the previous papers are doing. Let's see. Talk about percent in here. Okay, yeah, so these are percentages. All scores except for NIST and CIDR are percentages. So this is 3% error, not a rate of 3, which are different things. Okay, so that's less bad than I thought. So this is, so the error rate here is 12% rather than 12. And this is 0.5% rather than 1/2. Okay, so that's less bad. That's significantly less bad. Still not 0, which it could be. All right, even the extreme 5-shot setting, the SER is just 3.6%. Remarkably, in 2TG2, in an 80-shot setting, outperforms the naive model trained on the entire data set, which is 20 times larger. In the 5-shot setting, T2G2 performs on par with 80-shot naive. We take this as evidence that our template-guided input representation can lead to significant reduction in labeled data requirements. So what they're saying here is our model does well with, 5% of the data of a more naive model, so we're getting more bang for our buck, basically. That was what, figure 6 here. So the yellow, which is the rightmost one, is higher for blue, which is good, lower for SER, regardless of the number of data points. And then the middle one, which is red, is the schema, and then the blue one, which is on the left here, is the naive. Yeah, okay, interesting. So they're saying that, hey, our model sounds more natural. We're getting better results with less data, so it's more data efficient, which I always like to hear. Okay, so that's interesting. In Mrs. Rasa, bot builder samples in GitHub. Not entirely sure. Oh, we were talking about how to add teams. Yeah, you could also use GitHub if everyone is working on from the same code base. In this section, we conduct experiments to explore a few other aspects of our setup on the SGD dataset. For these experiments, we use naive representation since it is more widely adopted in prior work. We hope that these experiments will guide design choices in the future NLG models. Joint modeling. Joint modeling, instead of domain-specific models, could be beneficial in low resource settings if there is some similarity between the underlying structures. Furthermore, having a single model for all domains also reduces the maintenance workload and is resource efficient. For NLG systems, it could also help to design and maintaining consistent styles across domains and APIs. Yeah, we have time to finish this. Because of these merits, we investigate the effect of joint modeling on SGD dataset. We focus on the 12 domains that are present in all 3 splits. We train a single model on all these domains and compare it with individual models trained for each domain separately. As shown in Table 7, joint modeling leads to a win-win situation by improving BLEU and reducing SER while requiring fewer parameters and resource. So that's this one, and looking at models that were trained separately on each of these things. They have lower BLEU, higher SER. So this is 23%. Which is still very high, but it can be reduced to 5% with SER. No question. Single model on. Yeah, so my big question here is, are they only using part of the data for each of these domains, right? So if I'm looking at all the data for all of the domains, you know, having more data increases BLEU score, decreases SER, very, you know, predictable result. Are you using all of the data for each of the separate ones and all of the data for joint, in which case each of these is going to have like a 14th of the data as the joint models, and I don't think they mentioned that. So I think that would be a more fair comparison. But yes, I agree. If you can do, you know, multitask learning or joint modeling, definitely resource efficient. Role of context. Dialogue acts represent the semantic content of the system response, but they don't contain any information about the lexical and syntactic content. So this dialogue act is like, this is what the person's saying, but we're not going to tell you how they said it. The previous utterances in the dialogue history or context are important for generating good responses because they can help model conversational phenomena such as co-reference, elision, entrainment, lexical and syntactic alignment of responses, and avoid repetition. This would probably be called accommodation in the sociolinguistic literature rather than entrainment. Entrainment is a little bit more of a psychology term. Co-reference is things like anaphor, pronouns, who is that pronoun referring to. Elision is just like not saying. In phonetics, it's removing sounds based on particular context. In speech act stuff, I think it's more like just not saying things because you assume that the person already knows them. And then avoiding repetition is pretty self-explanatory. Context also helps add variations to the response generated across different conversations for the same system actions. Is that a good thing? I guess that's more natural, but I'm, you know, if I'm working with an automated system, I'm okay with repetition. Like, it doesn't bother me. Table 8 shows the performance of NLG as more utterances from the dialogue context are given as input. In these experiments, we concatenate the last K utterances to the system action representation from the naive method. The system action representation obtained from the naive method. The model benefits from the additional context, showing an improvement of up to 6 BLEU. Just a single context utterance, the previous user utterance, results in an improvement of nearly 3 BLEU. So adding more conversational context improves output. I think that's not surprising. A lot of the stuff that we do at Rasa uses conversational context quite heavily. So like TED, which is a dialogue policy, Diet, which is an entity extractor and intent identifier, uses conversation history. So cool result, not surprising. The evaluation for k greater than 2 is not completely realistic because we use the ground truth system utterances in the context during evaluation, as opposed to the utterances generated by the NLG model itself. Okay, so the conversations are as if an assistant was taking over in the middle of a human conversation. Regardless, improvements clearly point to effectiveness of the added context at the cost of more resources. We hope these results inspire more work in this exciting direction. And they're saying specifically in the NLG context. I'm not deep enough in the NLG literature to know if this is a novel finding. My assumption is that it is not. But I could be wrong. And here is the context. So as k, the amount of conversational context increases, error rate decreases, and this sort of proxy of fluency increases. Inclusion and future work. In this work, we propose schema-guided and template-guided input representation schemes for task-oriented response generation. Coupled with pre-trained language models, this template-guided approach enables zero-shot generalization to new domains with little effort. So being able to add new things for your assistant to do without changing things by hand. Moreover, we show that it can lead to drastic reduction in annotation costs. You need less data. We also prevent the first set of results on the multi-domain SGD dataset, which we hope will pave the way for further research in few-shot, zero-shot, and multi-domain language generation. Is their dataset? I don't think it is. I think someone else came up with this and they're just using it. Or it could be the author's dataset that they did for a different paper, but I don't think they presented the dataset in this paper. Well, in this paper, we use standard pre-trained models. Designing pre-training tasks tailored to sentence fusion is an interesting line of future work. So what they're doing is taking sentences and combining them. If they train their model to do that specifically, it might do it better. We also hope to apply T2G2 to languages other than English. Good to hear. Obtaining annotated data in non-English languages is an even bigger challenge, making the sample efficiency of our template rewriting approach especially suited to this setting. Okay, yeah, I'd say that's right. And I definitely like the study on sample efficiency. I'd also love to see that more in other papers, so solid. Another interesting line of future work is to investigate the use of T2G2 for generating user utterances, which could be useful for dialogue data augmentation and user simulation. Okay, so they say using this model to pretend to be the user and have user turns in a dialogue. That could work. My understanding of the literature to date on using natural language generation to generate text to train dialogue systems in particular is that it tends to become degenerate pretty quickly. Degenerate in this case means very unhuman-like. This requires adding the ability to generate utterances with stylistic variations to capture different user personalities while maintaining consistency in style and vocabulary over a single dialogue. So this sounds like something maybe the authors will work on in the future, which, yeah. I guess the thing for me is that once you have a system that works like kind of okay, getting user utterances is not the problem, right? So the way that we do, dialogue systems at Rasa is, you get something that's working, you get it in front of test users, and then you go through and correct and annotate what your model did with actual user utterances, and then fold those into your training data, update your assistant, and so on and so forth. So I don't know that that's a problem that you would have if you were using the Rasa way of doing things, but for a system like this, maybe. So, yeah. There were definitely some parts of this paper that I liked. I liked that they did human evaluation. I probably would have done it a little bit differently, but then I've had a lot of training in specifically human behavioral experimental design that I think a lot of people in NLP probably haven't. So I'm happy that they did it. I really like this work on looking at data sparsity. I think that was very interesting. I don't know about this section on joint modeling. I would want more information about the total data available to each of the models and trying to normalize that, which I think is something that we've run into before in the reading group. Yeah, so this seems like an interesting model for a very specific problem that I don't think most people have, but also I think that's pretty common in research, and that doesn't mean that it's a bad thing to research. I am not personally convinced that for any application that I'm working on or folks that I'm working with are working on, it would make sense to do, you know, take your templates, combine them, run them through a, you know, neural language generation, transformer language model, and then serve that to users. I just don't have, like, I don't have this problem where I want my assistant to be able to do 20,000 different things. Literally 20,000 different things. Usually I'm building things, or I'm working with people who are building things that are much narrower. So even, you know, Sarah, right, which is the virtual assistant that we have at Rasa that, you know, helps you out with Rasa questions. Pretty big, pretty complex, does not do 20,000 things, right? The sort of scope and scale of the assistant is pretty different. Yeah, also, there seems to have been at some point in the literature a switch from SER being a ratio to it being a percentage, and I'm not entirely sure when that happened. And it is very possible that I'm misinterpreting one of these papers, but I don't think in the original paper, yeah, they ever. So in this When et al. 2015 paper, I don't think they ever talked about SERs being a percentage, and at some point in the literature since then, it's changed into a percentage. I thought it was a ratio. So that does change our the order of magnitude, several orders of magnitude of the error rate. So yeah, interesting paper. Yeah. This isn't the paper we read. This is the paper we read. Yeah, I think that's all my comments on it. I enjoyed reading it. I definitely liked that the authors took a lot of different sort of approaches to evaluating their models, so that was great. I think the big things that I would want to change, I think probably the biggest one is for the human evaluation. I would ask about accuracy in a different way. I just think it's a little bit confusing the way that they asked it, and sort of open to more interpretation than I would want with that particular type of human task. Yeah, I think that's really the biggest thing for me. But I mean, some of the examples they had that they shared looked pretty good. Not as good as like a human written template, at least to me, but you know, pretty good. So I think that's about as good as you can hope for, right, with NLG systems right now. Great. So wrapping this up, tomorrow we're going to be back with live coding. I'm going to be continuing to work on my FAQ bot, and we're going to talk about things that are out of scope, and how to handle that when somebody asks for something that your assistant just can't do. So thank you for joining. I hope this was interesting or informative. Yeah, but not a bad paper, just not super, much less applicable to me and my work than I thought it was going to be, unfortunately. I thought it was going to be a lot more applicable, but that doesn't mean it's bad. All right, so I'm going to wrap that up. I'll talk to y'all tomorrow.